So our first speaker is Mr. Dan and Pichler. The title of his talk is Carbon Fiber Market Overview. And it's all yours.
Okay, thank you very much. First, Dr. Liu and Dr. Paul and everybody at the American Carbon Society for the chance to speak with your group and talk a little bit about the carbon fiber market. I'm very pleased to do this. So I've titled a paper, a Carbon Fiber Market Overview, but I'm going to be covering mostly about carbon fiber, precursor, and carbon fiber, but I will touch a little bit on the entire value chain down into intermediates and fabricated parts. So that'll be the scope of what we'll cover today. I guess first, a little bit about me as a person. I'm 40 years in the carbon fiber and composites business, more or less. I've worked with Hitco Carbon Composites since in California in the States since 1980. Did a little sabbatical with a couple of aerospace metalworking companies and came back to Hitco, and then they were bought by SGL Group in the late 1990s. And was with SGL Group in the US, in the UK, in Germany. Spent 3 years then on a contract with AXA, which became Dow AXA in Turkey, with HCC in Moscow, and the last 6 years since about 2015 with CarbConsult, which I'm back with a former SGL colleague. He's the other partner in CarbConsult. So I've been able to live and work all over the world. I've been involved in everything in the early half of my career: strategic planning, engineering, marketing, sales, and then general management for the second half of my career. Personally, I've got 2 daughters and they're populating the world with grandchildren. And I'm married to a nice Swedish lady for 25 years or something like that. And we're living summers in Sweden, Stockholm, Sweden, and the winter months in Venice, Florida. So we're very lucky to be able to do that. So one slide on CarbConsult. CarbConsult is a specialized consulting firm that does tailored strategic, commercial, and technical projects and solutions for clients, all the way up and down the value chain, from polymerization and precursor through carbon fiber production through CFRP part making. And our clients typically can be carbon fiber companies or advanced composites companies or chemical companies, often new entrants or investors thinking about entering the business and things like that. And of course, the areas we touch on is all end-use applications, from aircraft and sporting goods and industrial applications. So that's a little bit about where CarbConsult is positioned in all of this. So today's presentation, as I said, I'm going to focus mostly on the upstream end of the value chain. So the carbon fiber, what's happening in the carbon fiber market, both from precursor and carbon fiber, and then specifically about the market for carbon fiber and the applications for carbon fiber. And at the end, I'll also touch on supply and demand situation and who the players are. And I always think that is kind of interesting background in this kind of a thing. And then, of course, I will touch briefly on the stuff on the right, the intermediates, be they fabrics or non-crimp fabrics or prepregs or pultrusion or whatnot, and on a little bit on the making of parts from hand layup through automated processes that we're seeing developing today. So that's the scope and agenda for today's presentation. So first of all, how big is the carbon fiber market? Well, the carbon fiber and precursor market is about a $3 billion industry, and it's a little more than 100,000 metric tons of carbon fiber, a bit more than double of that on the precursor side. But in terms of an entire industry, almost all carbon fiber goes through some intermediate processing, fabrics, prepregging, whatever. And that's another 50% or nearly 1.5, 2 billion in terms of value. And then the CFRP part making actually is the largest part of the industry. There's more money spent making parts than there is in making the carbon fiber. So overall, when we think about the carbon fiber and composites, the advanced composites industry or the carbon fiber composites industry and market, we tend to think of it as roughly a $10 billion industry. Well, how big is that compared to other structural materials in the market? Well, in 2020, we estimate the carbon fiber market was 109,000 metric tons. Unfortunately, there is no carbon fiber industry association that collects data, so there is no kind of known number as to what the industry does. But various people do come up with estimates. So this is our estimate of the size of the carbon fiber market. The good news and the bad news is the carbon fiber market has never been bigger. The bad news is it's really small. The fiberglass market is 50 times larger. The aluminum market is 100 times larger. The steel industry is 20,000 times larger. I mean, these are huge differences in terms of how big is our industry. And so we always have to be humble, even though it's a $10 billion industry, that the carbon fiber market and the carbon fiber industry is itself very small. So a little bit of a complex slide, but let's go through it. So a word about pan precursor. Carbon fiber is made from precursor. The act of making carbon fiber is a conversion process, usually from a white fiber into a black fiber. So what are we doing here? Well, first of all, when we speak about carbon fiber, most of the time we're speaking about pan-based carbon fiber. Pan-based carbon fiber makes up 95% or more of all carbon fiber. There's pitch carbon fiber, and there has historically been a little bit of rayon or viscose-based, cellulose viscose-based carbon fiber. But basically, when we talk about high-strength carbon fiber, we're talking about pan polyacrylonitrile based carbon fiber. There could also be other things in the future, and there's research going on, and people have tried projects over the years with polyethylene or basalt or lignin or other natural materials. But really, when we say carbon fiber, a guy like me from the industry, when you say carbon fiber, you mean pan-based carbon fiber. So the A in pan, polyacrylonitrile, stands for acrylonitrile. And the acrylonitrile market is about a 5 million metric ton market. And it's used to make ABS plastic and other plastic chemical products. And it's used to make acrylic fiber. And carbon fiber precursor is a kind of a specialty product of acrylic fiber. So when we think about carbon fiber, we think about pan-based carbon fiber, we think about pan precursor, and we think about acrylic fiber producers, because they're the ones, when you're making pan precursor, you're making an acrylic fiber. So in the acrylic fiber world, it's a big world. There's more than 2 million metric tons of capacity. There are 45 producers in the world. They go from 20,000 tons to 300,000 tons. And 70% of acrylic fiber is made in Asia. When we talk about pan precursor, it's a subset of that. There's roughly 15 producers, 1 to 50,000 tons of capacity. The industry needs to make 250,000 metric tons of precursor to make 100,000 tons of carbon fiber. And basically, these are the guys, for the most part, it's a one-to-one list of carbon fiber producers. And I've got a chart on this that shows, these are like the big acrylic fiber producers in the world, the Axis and the Gillen chemical fibers with their 300,000 tons of acrylic fiber capacity. And then all the other ones with their 100,000 tons of acrylic fiber capacity, the Draylon, Dolons, the Mitsubishi, Toray, Zoltec, Formosa Plastics, Thai Acrylic, all those kind of guys. And in the blue bars, I'm showing the acrylic fiber producers. And in the red bars, I'm showing the carbon fiber precursor producers. And you can see, therefore, how the carbon fiber precursor guys kind of fit in and are a subset of acrylic fiber production. Okay. So we're going to talk about carbon fiber today. We're going to talk about applications. Where is carbon fiber used? This is the subject of the presentation today. So we'll talk a couple slides about aerospace, about sporting goods, wind turbine blades, pressure vessels, infrastructure, automotive, marine, compounding, tooling, and others. So these are all the uses of carbon fiber. And then we'll learn throughout the 45 minutes, you know, which are the big ones, which are the growing ones, et cetera, and so forth. So a little bit of history before we go too far. The history of carbon fiber growth over time is interesting. Number one, it's been rather consistent. Whether you do a compound growth rate over 10 years or 20 years or 35 years, you always get 9 or 10% as the compound growth rate. So it's been rather consistent, the growth of our industry over a long period of time. It started in the mid-70s with sporting goods and military aircraft applications. By 1985, when the industry was on 5,000 tons, it was 1/3, 1/3, 1/3. 1/3 industrial, 1/3 aerospace, 1/3 sporting goods. And in 95, at 13,000 metric tons, it was still 1/3, 1/3, 1/3. And then all of a sudden, wind came in. And in one lump, in a couple of years, it took the space of 20% of the demand for carbon fiber. And demand jumped to about 25,000 tons by 2025. And then by 2015, BMW and Automotive had come in, and the industry was on 62,000 metric tons, and 20% of carbon fiber was used in automotive applications. And then here we sit today, 109,000 tons last year, 113,000 tons this year. We'll talk about the details of that later on. But we're looking at an industry that's roughly 15% aerospace, less than 15% sporting goods, and more than 75% industrial applications. So the conference topic today, being industrial applications and recycling of carbon fiber, is right on for where the industry is today. A little bit about products in the carbon fiber world. This is not a one-size-fits-all kind of industry. You see a lot of these charts, like on the left with this L-shaped chart with the high-strength carbon fibers going up and down on the left, and the higher modulus carbon fibers stretching out to the right. And my simplified view of that is that if I look at automotive, wind, aerospace, sporting goods, the bigger end pressure vessels, the bigger end use applications, I can more or less categorize what kind of carbon fiber is used in those applications. And I can see where the standard grade carbon fiber, 3.5 to 4.5 GPA, 230, 240 modulus, those kind of products are used. I can see where there's a typo on this chart. The middle column should say 4.9 GPA. So the higher strength standard grade carbon fiber at 4.9 GPA for pressure vessels, for aerospace and support and construction and infrastructure applications. And then where the higher strength and the higher modulus carbon fibers fall in their applications. So generally, in terms of standard modulus, in terms of 230, 240 modulus, that's 2/3 of carbon fiber that's used, and about 1/3 is higher modulus than that, intermediate and high modulus carbon fiber. Most end-use applications would like to see a standardized either they have a standardized product or would like to see a standardized product. But in the aerospace world, it's very complex and there's a lot of specifications, and it's really a very specialized world. So the conclusions about products in carbon fiber, and for those of you who are engineers or getting started in this industry, one size doesn't fit all. There's different carbon fiber products for different applications, and there are hundreds of specifications. So there's interest for everybody. So let's touch briefly on the applications. So in aerospace, we see now new aircraft with nearly 50% of the dry weight being carbon fiber composites for applications in fuselages, wings, tails, doors, interiors, also in aircraft engines, also in military aircraft and other defense applications, and all the tooling to make all that. So this is kind of where we've got to over 30 years in the aerospace world. And in terms of demand, this is one of the more interesting segment demand charts to show you. The aerospace industry had been growing rather nicely year by year until 2019 and until the beginning of 2020, actually. And then COVID hit and the commercial transport industry was basically shut down. And Boeing and Airbus cut way back on their production rates. So in terms of where we might have been without COVID with a growing market, we had 25% contraction in 2020, even a little more this year, as now we have a full year of the low rate production. And the industry expecting to dig itself out over the next coming years. So from this point forward, there's good growth, 10, 12% in aerospace, but from 2019, it's only probably a 3% growth rate if we look over a long number of years. Sporting goods, and by sporting goods, we're talking about fishing rods, golf club shafts, all kinds of rackets, helmets, bikes, boards, poles, all these kinds of things. Historically, 75% of all sporting goods have been made in China, and China has been the world's factory for sporting goods equipment. And in fact, up until as recently as 10 years ago, about 2/3 of the carbon fiber consumed in China was for making fabricated sporting goods. And so the sporting goods market, there's a little, if you look carefully at the chart, you'll see a little bit of an uptick in terms of growth rate in 2020 and 2021, as we all decided that doing outdoor stuff was a good way to avoid the pandemic, et cetera, and so forth. So there's been an uptick in demand from sporting goods, but we see relatively strong and consistent growth rate continuing into the future for sporting goods as we have in the past. Wind applications in wind turbines. Carbon fiber is used in many wind turbine blades today, including those designed by the big Western producers, Vestas, Gamesa, Enercon, Nordex, and others, and the big Chinese producers, Minyang, Dongfeng, Goldwind, everybody. Large-scale use of carbon fiber in wind turbine blades began in the mid-2000s. Vestas and Gamesa were the first to use big quantities. And its carbon fiber has evolved to being used in the spar caps in many of the large wind turbine blades, particularly those more than 45 meters long. So carbon fiber, it's not making up the whole blade. It's maybe making up, 5 or 6 or up to 10% maybe of a wind turbine blade's weight. And because it's more expensive than glass, a larger share of the cost. And so a medium length blade, a 40, 50 meter long blade, might use several hundred kilos of carbon fiber in a blade. A large blade, like for offshore at 100 meters long, might use several thousand tons of carbon fiber per blade. And what we see over time is the trend to larger and larger blades, both onshore and offshore. And we see offshore taking a bigger share of the market going forward, even though it's only 7 or 8% today. And so we have kind of a funny lumpy curve for demand for carbon fiber in wind turbine blades. And this is a combination of the kind of turbines that are being built, the kind of blades that are going to be built, the volume of turbines that's being built, and the shift to more and more larger turbines, both to capture low wind onshore and to capture offshore over time. But what we see is the biggest market in carbon fiber today only getting bigger by doubling again in the next 4 or 5 years. In pressure vessels, we have CNG tanks, we have hydrogen tanks, we have SCBA tanks that firemen are using, and deep sea divers and things like that. Growth is continuing at an aggressive rate, particularly expected for hydrogen in the future. Natural gas buses account for 20% of all new buses produced today. And the payback for a CNG bus happens over about 3 years. So it's actually a good payback for the cities and municipalities that are operating these fleets. Also, electric vehicles may come in, and then whether it'll be CNG or eventually more electric vehicles, you know, that has to come into your thinking when you model this. But there are some people in industry that expect 100 times growth in pressure vessels by the next 10 years. Seems optimistic to us. We haven't forecasted this, but it's an upside that we can think about in our industry. The other interesting thing is these high pressure tanks, high pressure vessels, use one of the higher strengths of carbon fiber, and only a few of the carbon fibers can actually produce that material. So it's an interesting sub-market within the carbon fiber world. In terms of where we are, demand and growth, we're at about 15,000 tons today and expecting a 7-8% growth rate in the future. And as I said before, it could bend upwards if hydrogen takes off faster than we've accepted it in the modeling that we do. Carbon fiber applications in infrastructure and energy. We see things a lot in the infrastructure retrofit business where pultrusions or dry fabrics are being bonded to the underside of bridges, walls, tunnels, things like that. Also, and you know, the world is, there's a lot of earthquake places in the world, including our colleagues in China who have about half of the world's earthquakes every year. So it's a big, interesting and growing industry. It'll be interesting to see how the US, Biden's new infrastructure program affects repairs to bridges and things like that. And some of those might take retrofit kits like these to strengthen them. So this is going to be an interesting market going forward. Offshore oil and gas, for years, the industry has been developing, testing, and trialing drilling risers, production risers, choke and kill lines, tendons and tethers, and things like that. And in high voltage cable applications, bridge stays, electric cables, tensile things like Kona has carbon fiber straps to hold up very high elevators in 100-story buildings and things like that. So interesting applications, a variety of small applications in infrastructure and energy. But it all adds up. It makes up about 10,000 tons of the market today, and a good growth rate on this one, 10 or 11% growth rate expected as more and more applications come on scene. Automotive applications, a lot of small words here, sorry for that. So just look at the pictures. Since 2013, BMW has been making the i3 megacity battery electric vehicle, 30,000 cars a year production rate, which is about 100 a day. That production will run through this year, and I think it's expected to end after this year. But the value chain was created by SGL and BMW, and that model alone is estimated to be consuming 3,000 or 4,000 tons of carbon fiber per year. Then BMW moved on to the 7 Series with a number of maybe 15 or 20 components using carbon fiber bonded to them or individual parts. Typically, you can see in the highlighted picture there around the ABC pillars and across the roof structure and stuff like that. And that's using 1,000 or 2,000 tons of carbon. And then you have a whole bunch of other things. You have carbon look parts, you have appearance parts. Seems like every automotive OEM is playing around with a rear deck lid or bumper components or fender components or drive shafts or here and there, all kinds of different things, as well as there's a lot of interior trim parts. So, and then finally we have carbon fiber wheels and brakes, and racing car parts, which are used not only as some OEM parts, but as you can buy them aftermarket parts. So the use of carbon fiber in automotive applications is interesting. If you take out the I3 program, which is the light green bars on the left side of the chart, you see steady growth in the industry at 7 or 8% a year, 8 or 9% a year, actually. But then you see the impact of a big program, of one program making 30,000 cars, coming on and stopping it. And I think we will see this going forward as adoptions in automotive come and go. In the marine industry, we have everything from very expensive items down to $10 items. So carbon fiber is used in marine applications on super yachts, ships, yachts, boats, canoes, watercraft, all kinds of things, trim and decor parts, everything from hulls, masts, spinnakers. You see some nice pictures there. You see that nice little red boat there, that Candela electric boat that foils out of the water. That's actually made about 100 meters from my apartment in Stockholm. So we see those every day out in the water. But it's an interesting industry, a lot of different applications. We have a boat, we spend 30 or 40 days on the water a year in Stockholm. We see black stuff every day. Unfortunately, it's only a couple of 1,000-ton market. So it's growing at 6 or 7% a year. Everybody wants their black parts, they're attractive. But it's not a huge market segment as yet. Short fiber, typically it's standard grade fiber, chopped, usually with special sizing on it. And these make engineering plastics, like for components in our computers, our mobile phones, our printers, our hard drives, and that. Also can be used for conductive flooring applications, a number of different application areas. Typically, chopped carbon fiber is more expensive than continuous carbon fiber on the spool because of the extra processing done to put the special sizing on and to get it chopped and bagged and ready to be shipped off. Milled carbon fiber is typically can be made a lot from recycled or waste carbon fiber. It's typically unsized, typically milled to 80 or 100 microns in length. And because it's a byproduct or a recycled product, it'll tend to be less expensive than standard grade carbon fiber. So chip tray carriers and buoyancy aids and some of these others have been some of the early and first applications of milled carbon fiber in plastics. And that's about a little bit, just under 10% of the market, growing at about 5% a year. A huge variety of end-use applications for short fiber. So a couple of slides on making CFRP parts and touching on the technologies involved there. So when we have carbon fiber on a spool and we want to make a physical piece part that's a door or a chair or an airplane wing or a wind turbine blade spar or whatever it is, we typically have to go through some intermediate processing, and then for sure we have to go into some part forming kind of processing. So the world is actually quite complex here when you talk about all the different kinds of intermediates and intermediate processing and which one's optimum for the molding process or the forming process that's going to be used to make the part. Just a couple of quick words on that. Prepregs is one of the most common forms. It can be unidirectional or a woven fabric, can be either thermoset or thermoplastic based resin in it, and typically made on fairly complex, expensive kind of production lines to do the prepregging, like the picture shown on the bottom left. Fabrics, a lot of fabrics are woven, a lot of non-crimp fabrics out there. Also rovings and tapes can be used, some 3D weaving, which is very complex. And this is an interesting world because there's in every geographic region, there's 50 or 100 intermediate processing kind of people. So there's a lot of intermediate processors in the world. And then when we think about making CFRP parts, yesterday's technology was very much this hand layup, autoclave cure. We've seen these pictures. We have these images of parts being made by guys in blue gloves. And, going to technologies for the future, some kind of a resin transfer molding, some kind of wet compression molding, or thermoplastic processing, or something else. And everything that you see on this, when you go to a JEC or a big fabricating convention, then you see this common theme of this world is going to be sophisticated. It's going to be based on large scale factories and production, big presses, big equipment, automation used, and significant investment required. And that is also that as fabrication is changing and evolving, then the intermediates are evolving. So no matter whether it's an aircraft or wind or auto parts, where everything was hand layup a Prepreg originally, it's now going to different kinds of automated processes that are involving the intermediates. So it's a changing world we're living in, not only in CFRP part fabrication, but also in intermediates. In terms of the complexity, I would say it's quite complex in our industry. And maybe that's why there's, in some areas, few players. So in precursor and carbon fiber, we have 15 or 18 players in the world. In intermediates, we have 200 or 300 players in the world. In CFR fabrication, we have 2,000 or 3,000 people in the world, everything from a garage shop to the sophisticated factories of Boeing and Airbus, and everything in between. So the investment cost is different. The investment cost in precursor and carbon fiber is very high. The investment cost in a large automated fabrication shop is very high. And the technology barriers are therefore, high to very high, depending on where you are in this scale. So it is a complex industry, and that's probably the reason why we're as small as we are. So a couple of slides on demand and supply. So putting it all together, this is what I've told you so far. I've told you that the global demand for carbon fiber in 2021 is about 113,000 metric tons. Wind is the biggest segment with 28,000 tons. Aerospace and defense at 16,000, sporting goods at 14,000, 15,000, pressure vessels, infrastructure, all of those. What's interesting also is this is the global demand pie for carbon fiber in 2021. About 75% of that carbon fiber is consumed outside of China. About 25% is consumed inside of China. And China is no longer about sporting goods. It is about also wind, pressure vessels, automotive, aerospace, defense, and other applications. So short fiber compounding. So the world is constantly shifting and constantly evolving for us. In terms of what happened to our industry in COVID times, it's quite interesting to see that aerospace has contracted. It contracted, we think, 24% in 2020 and another 3% this year before it starts recovering and growing. But all other applications were not so much impacted. In 2020, demand for carbon fiber was up 10% in non-aerospace terms as in 2019. And even this year up 6% over last year. So there was a snap effect last year, but it's continuing this year. So overall, we're seeing, about the growth rate in total has about halved in 2020 and 2021 before it gets back onto its 9 or 10% track going forward. So that's what we see. We see that there's pluses and minuses in various segments. That COVID has had an impact. That's why we have this dip in the whole curve is shifted down maybe a little bit in 20 and 21 from where it was in 2019. Aerospace demand took a big hit and will take time to recover, especially the twin aisle aircraft, the 787 and the A350, the ones that use the tons and tons and tons of carbon. But our overall forecast is fairly robust, continuing from today's point, about 9.7% out through 2026. And if we think beyond this, if we were thinking of a 10-year horizon instead of a 5-year horizon, we wouldn't see much that would change. We would see the continuation because the underlying demand continues to be growing, it seems. So who are the players in carbon fiber? This chart is hard to read for you. It's 1970, 1980, 90, every 10 years across the top up until today. And it shows the 4 or 5 or 6 players who have been involved for 40 or more years in carbon fiber. It shows some who have come and gone. It shows the more recent entrants in the 80s. It shows some like Conoco that came in and went out and spent a bunch of money along the way, as well as others who have failed along the way or been gobbled up by others. And then and it shows fairly recently in the last 10 years, AXA coming on stream and Chinese producers coming on stream. And so we're left with this, 13 or 15 players in the world today for carbon fiber. And in terms of capacities, this is kind of how it stacks up. So these are the published nameplate capacities of the various carbon fiber producers. Toray together with Zoltech with a very large market share. But then a number, anything over 10,000 tons is probably significant. So then you've got, 5 or 10 in the pretty decent size range of 10,000 or more tons of capacity. So on the left, in blue, you have the Western producers, and on the right, you have the Chinese producers. And you should be developing an idea in your mind that the Chinese producers are actually today making some pretty good products. They're making, 30 or 50% of what's consumed in China is being produced in China as carbon fiber. And so the number of imports into China has not grown over the last several years like the overall demand has grown. And then in terms of product mix, there's a little pictogram up on the right is that in terms of small tow carbon fiber, 1 to 24K, that's 60 or 70% of the market, and it's falling every year. And the 50K, 48K to 60K market is around 30 or 4% of the market and growing. So if we went back 50 years and created a chart of carbon fiber, it would look something like this. So capacity and demand have grown over the years. Demand has several times caught up with capacity and caused a pinch and caused then producers to invest in more capacity. Carbon fiber is expensive today, but it was 10 times more expensive 50 years ago. So the price of carbon fiber has actually come down a lot over time as the industry has gotten bigger. And the carbon fiber plants have gotten bigger, where we see thousands of ton, a couple thousand ton lines, and we see several lines in a building and things like this. So the conclusions I draw from this 50-year chart is, can the price of carbon fiber be lower? Yes, of course. Can it be 50% lower? No. Can it be incrementally lower? Yes. And then can the price of carbon fiber go up? Well, yes, of course. I mean, it's pan-based carbon fiber. It's an oil-based product. It's a petroleum product, acrylonitrile. So if the price of oil goes up, the price of pan will go up, the price of carbon fiber goes up. But also, if the price of oil goes up, the value of lightweighting and alternate energy and the things that are facilitated by carbon fiber go up. So I think that carbon fiber people should cheer for a high oil price. So second last slide here on supply and demand situation. What I've showed you is on the left. I've showed you that it looks like there should be plenty of capacity available in the industry. But if you understand all of what I told you about what's happening in segments and things like that in the previous slide, aerospace carbon fiber capacity, which is not highly utilized right now, cannot be readily switched to producing industrial grade carbon fiber. The format's not right. The strength might not be right. And if one assumes that not even within the industrial carbon fiber world, if one assumes that not all carbon fiber can be supplied by any industrial grade, then there's qualifications and preferences in the way. And then on top of it, we're having this whole supply chain issue and engineers can't travel around the world and things like that. So if I redraw my chart for in non-aerospace carbon fiber outside of China and including what special grades have to be imported into China, I get the chart on the right that says there's a problem in the supply of carbon fiber. And we in fact do see this in the market today. There are some carbon fiber shortages for industrial grades of carbon fiber, which is a first for me in 40 years of observing this industry. So that's where we are, and we have maybe 5 minutes to talk after I wrap up here. So my conclusions from today is the market for carbon fiber is growing, and it's expected to continue to do so for any planning horizon. All market segments are growing, including aerospace is recovering, but the industrial applications especially so on the growth side. The landscape of the carbon fiber producers is changing. New players have entered. Who will be most successful? We don't know. There appear to be shortages happening today, and additional capacity will be needed, and who will do it? How we make our CFRP parts is evolving, and mass production and new fabrication methods are coming on the scene. And the world of intermediates is changing accordingly. And recycling, which you'll see from Brett Schneider later on, is becoming more recognized and more demanded. A lot is going on in that area. There are actually more people working on recycling carbon fiber than there are carbon fiber producers in the world. So it's a very interesting area. But finally, think about this. I showed you the 50-year chart. So in the first 50 years through 2020, the carbon fiber produced its first 1 million metric tons of carbon fiber. And in the next 6.5 years, it will produce its second 1 million metric tons of carbon fiber. So we see great opportunities for carbon fiber and composites, no matter where we look. That's all I have to say. Thank you very much. And I'm happy to take a couple of questions as up to Dr. Liu's limit.
Thank you, Dan. That's a great overview about carbon fiber and applications. I think we have 4 or 5 minutes for the question and answer. So let me read some of the question here. The first question is, in slide 40, you indicate the capacity increase. Is this increase coming from the pan or pitch source?
Yeah, the chart that I showed you there, all the charts were pan-based. So what we have is we have Zoltec in Mexico have announced an increase of 5,000 tons. Torre has for their Zoltec facility. Dowaxa have announced a couple of 1,000-ton increase in capacity, and Hyosung have announced a couple of 1,000-ton increase in capacity. So those are the producers that have announced increases in capacity. Those are the ones that I show as the bump on the chart. They're all pan-based guys, and they're all for industrial applications.
Thank you, Dan. Another question, with respect to the balance between carbon and glass fiber, do you see that carbon fiber is replacing glass fiber, or they're joined together to grow?
Yeah, no, carbon fiber, it depends, okay? You know, in an automotive application, carbon fiber is maybe not replacing glass, it's replacing steel. In a wind turbine blade, I remember in 2005, the Vestas guys said their blade with a few hundred kilos of carbon fiber in weighed 6 or 7 tons instead of an all glass blade of 10 or 11 tons. So in that case, 500 or 600 tons of carbon fiber went in, 3,000 or 4,000 tons of glass came out. So it was disproportionate what was happening in that kind of an application. So it really depends on the individual application. In pressure vessels, carbon fiber is generally not replacing glass. So it's different instances. It depends on the specific application and the engineering and the solution that the engineer is going for.
Okay, thank you, Dan. How much of the carbon fiber manufacturing cost go to PEN? I think the question is how much cost of carbon fiber go to the PEN precursor?
Yeah, I mean the PEN precursor is a couple of things, right? It's the chemical, it's the acrylonitrile, which is more than 50% of the cost of PEN precursor is the chemical. But then you've got steam and electricity and labor and engineering and stuff like that, you know, other value adding costs. So if you go roughly, if you think of industrial grade carbon fiber, not an aerospace product that's very high value, but of an industrial carbon fiber like an automotive application or a wind turbine application, you can think roughly that half the cost is the precursor. And of that half that's precursor, half is the acrylonitrile and half is the everything else to make the fiber.
Thank you, Dan. If oil price goes up, there are more needs for EV cars. Will EV cars need more carbon fiber?
EV cars need heavy batteries. And when you put heavy batteries in the car, you got to take out something else. And so they take out weight in other areas, and carbon fiber is the lightest thing you can do that we can think of to make a structure, a body for a car, right? A steel body in white weighs 400 kilos, an aluminum one weighs 200, and a carbon fiber like a BMW i3 weighs 100. So the lightest thing you can do is carbon fiber. So if you're going to put in a bunch of heavy batteries, then I think ultimately lightweighting is still a big, you know, it's going to happen in the automotive world.
Okay, thank you, Dan. Last question. Are there unique challenge to using carbon fiber over other materials?
Yeah, absolutely. I mean, you know, in an automotive application, if you have a regular car and you smash it up, you take it to somebody to repair it and they pound out the metal or they cut out the piece and weld in a new one. You know, what do you do when you got a CFRP structure that's 15 layers thick and you don't know if it's delaminated halfway in between? You have to send it to a special place. So there's challenges to making carbon fiber parts, and there's a challenge to having carbon fiber parts in service. And so there are, yes, there's room for engineers in the world.
Thank you, Dan, for all the answering to the question. I think we have a breakout. If some of you have more questions want to discuss and with Dan, please and go over there after the next speaker.
Okay, thank you very much, everyone.
Again, thank you, Dan. Let's give Dan a virtual round of applause.
Thank you. Thank you.